Good morning, everyone. My name is Sheldon Lowenyu. I'm a field engineer at Rancher Labs, and I'm here together with Ramon de Boer. Maybe Ramon, you want to introduce yourself?
Yeah, sure. Good morning, everyone. My name is Ramon de Boer. I'm one of the SDs within the Prisma Cloud team with a focus on cloud security.
Awesome. Good morning. Thanks for doing this with us. So what we are actually going to be doing today is a meetup style session. So I'll be showing you, I'll start off by going into uh, some Rancher basics, like what does Rancher do, multi-cluster stuff, how do we add security into that environment, and then we'll go dive in a lot deeper. At least Ramon will help you dive in a lot deeper into how to correctly secure your Kubernetes environments as well. So this is GoToWebinar. So if you have any questions, you can just post it in the questions field. There is a questions box. There's also a chat box, but that's usually just for one-way traffic. So anything I might paste in there, you'll be able to see in there as well. But all of the questions, you can just post in the questions box, and we'll make sure to probably at the end of it, because while presenting, usually we have, if I'm doing a rodeo, for example, there is a fellow rancher colleague on the other end answering questions. But since this is now two different people, companies, uh, we'll leave the questions, we'll leave the answering to the questions to the end. I don't have any slides, but I just want to go through ranch itself. So I'll just start off. First of all, the first thing you see, of course, if I'm not mistaken and my screen is sharing correctly, is the Rancher login page. Um, and I'm not hearing anything else, so I'm guessing I do. So what you can see here, I've actually got two Ranchers set up. Well, one is mine and one is our demo environment. As you can see, one has GitHub set up and one has the local users. I'll just log in to my own Rancher environment, which is just a clean, newly built environment. And the first thing you'll see here is clusters. And that's also the most important thing, well, one of the most important things you need to know about Rancher. Rancher is a multi-cluster management solution. So for all of your Kubernetes clusters, to have them in one place and manage them centrally with central authentication and all being uniform and adhering to the same rules, or at least you can do all of that from one single pane of glass. So we're going to go into Rancher and we're going to deploy a bunch of clusters just to show you how easy it is to just start using Kubernetes. Because of course, for the people that might have already started using Kubernetes or deploying Kubernetes clusters, there's a ton of ways to do it, right? So if you, for example, do the CKA, you might have to do or might have to use kubeadm. If you do follow Kelsey Hightower's Kubernetes the hard way, you'll be doing it with Hyperkube, with the binaries themselves, creating your own certificates, all of that good stuff. But of course, we've got kops as well. You've got Minikube. There's a bunch of tools that will set it up for you as well, including we have two Kubernetes distributions as well that you can just deploy just a Kubernetes distribution. However, if you go in and deploy all of those different distros, that's, I would say, do that if you can, because that's how you learn, right? So maybe start with kubeadm or something like Minikube or K3s. Start easy and then maybe go into Kubernetes the hard way to just learn more about Kubernetes, at least if that's what you want to do. Of course, not everybody wants to know the nitty-gritty of Kubernetes. And if you don't, I'll show you easy ways to just set it up yourselves. So let me just start off with building a few clusters, right? Because I've just logged into Rancher. I'm not seeing much in here. All I see is a local cluster, and this local cluster is an imported cluster. All this means is that currently this Rancher instance is installed on top of a Kubernetes cluster. So with Rancher, you can deploy it in multiple ways. And one of the simplest ways is actually a Docker run command you can just spin up, but that's only purely for testing. Any other way, you would either create an RKE or the Rancher Kubernetes engine, or a K3s cluster and then deploy Rancher on top of that cluster with Helm. So this local cluster you're seeing here, that's just actually the cluster that Rancher is sitting on and has been integrated with. So it's using its etcd, it's deployed its custom resources. All of those things are in that cluster. So you don't actually want to use this cluster other than maybe enabling live metrics or enabling some type of maintenance tool or something like that. Maybe if you need to add something custom in there only for that cluster maintenance. However, workloads and stuff like that, I wouldn't do. So let's just start off by creating a bunch of clusters, right? So you just started off with Kubernetes, you heard about this Rancher thing, you want a cluster, and you just want to start using it. If I click on Add Cluster, you'll see a bunch of options. One of them being from existing nodes. So I can add a cluster, I can provision a Kubernetes cluster that is going to be based on nodes that I already have running. So you might have some server sitting somewhere, or some VMs already active, or some bare metal. Whatever you have, it's already there, it's already running. All you need to do is use those nodes. I'll just go into this one and then we'll follow the other ones as well. If I click on this, you'll see that, okay, let me first enter name. So I'll do demo custom. And then if I scroll down, you'll see I've got a bunch of options. Of course, Kubernetes versions, these are also updated automatically for you. So I'll just leave it on the latest one. This Rancher tag that you see here, or naming, is not like we fork Kubernetes or create some special fork of it. It is indeed like it is a copy of this Kubernetes version, which we then test and make sure that it's completely error-free, right? So we make sure it runs with Rancher. But if something happens, for example, there's a CV in Kubernetes, or perhaps maybe in Docker or one of those solutions, we can then patch it and push it out to everybody. So this is not a special version of Kubernetes. It is just upstream Kubernetes, but a copy of that, so we can quickly patch if necessary. I'll just leave it on the latest one that we have in here. I can select multiple network providers. I won't change anything here as well. If I have Canel selected, I can do, for example, single cluster multi-tenancy by just enabling project network isolation. All this is basically is these Calico network policies. So Canel being a combination between Flannel and Calico. And if you have Canel, you can then just select this, and by default, any new project will then be logically separated from all other projects. You might also think, what is a project? I've known Kubernetes for a while. I've never heard of that. And that's true. So in Rancher, we have a concept called a project. And a project is just a collection of namespaces. However, if you were to remove Rancher from your environment, it will not break anything, because all the project does is it propagates any configurations that you set to the project to the namespaces inside of that project. So you can remove Rancher and thus the project, and everything would still keep running. And that's one of the benefits of using Rancher. Any cluster you create with Rancher, or import or use or manage, whenever you want to remove Rancher, we actually give you the way to remove it. And then your Kubernetes clusters are just there to be used as standard Kubernetes clusters. So very easy to just try out. If it doesn't fit your need, you can also remove it. I'm not going to change anything. I'll just scroll down, click next. I won't go too detailed into everything. Here you can see what this custom cluster actually does. I can select a role, etcd, control plane, and a worker. So I'll select all of them because I have one machine, and I want to have that one machine have all of the roles. Here you can see that all this does is give me a Docker run command, which then deploys the Rancher agents and then connects to Rancher. So if I copy this and then let me spin up, I'll just open up a terminal in here. Let me increase this a bit, and then I will go to a custom cluster. Let me copy the IP. So on this one, SSH. So this is just a machine on DigitalOcean, as you can see, it's completely new. And actually, I can't currently do this because I forgot something. Because one of the things that you have to do to use a custom cluster, like you saw, there is a Docker run command that you need to run. So of course, all you need to have is a machine with Docker on it. So no Docker run. So I just forgot to install this. So while this is just installing, I'll just go on to the next one. So I'll just split this pane horizontally. And then let me go back to Rancher. Here we go. So this one is actually already created. And if I click done, it's just going to wait for me to just copy and paste that somewhere. So this is just going to stay pending until I paste that command somewhere. If I go in and add another cluster, I can go, for example, to import an existing cluster. And I'm currently working on also getting my CKA certification. So I have a kubeadm cluster set up. So if I want to import that already existing cluster, I can just click import cluster. I'll do demo import. I just click create. And all this gives me is a kubectl command to put in that already existing cluster. So also for this one, if I go to that already existing cluster, let me get that IP. There's always a bunch of IPs to get. So if I go to that one here, so this is actually a existing Kubernetes cluster. If I do get nodes, you'll see that's a 2-node cluster, and I've set this up manually with kubeadm. So if I want to import this existing cluster, all I would have to do is just paste in that kubectl apply command. It will set up everything it needs to set up. If I do get this, you'll see that this is just going to start spinning up the agents necessary for Rancher to then manage that cluster. So not a lot really happening. All Rancher is doing is adding some agents into that cluster, existing cluster, and then we can start using it. So if I go back to Rancher, you'll see that this imported cluster is now actually already imported. So if I just close this one, pods, here you'll see that everything is up and running. So it added a cluster agent and a node agent for every node, which is running on each node. And that's it, right? So going back to Ranch, you'll see that now I have an imported cluster, which is running 2 nodes. And I can now also just start using this cluster. I'll jump into why you would do all of this in Rancher, but let me spin up a few clusters while we do that. If I go here, the custom one is currently spinning up, so I think Docker should be installed right now. Let's see if this one is here. So if let me get that command back. This was the Docker run command that's giving me the token to that specific cluster I created and has those 3 roles. So if I run this command on that node, this is just an existing node that has whatever, a Linux OS and Docker running on it, and I can just attach this node either to an already existing Kubernetes cluster that's already an existing custom cluster, or I can provision a custom cluster directly. So if I, for example, do with this one, I would do a Docker PS, because this one does not have the kubectl client installed on it. So this is going to be Rancher deploying or provisioning a Kubernetes cluster on it. So this is just going to spin up a bunch of containers first to initialize, and then RKE, the Rancher Kubernetes engine, is going to spin up or provision a basically single node Kubernetes cluster. So this one, it'll just continue to go. So I'll go back to Rancher while this moves along. Of course, you have from existing nodes, you can import any existing clusters. If you want to use EKS or AKS for some reason, because you do want that environment managed, you can also just deploy it from here. We recommend use the custom node or the cloud VMs basically, because these are where Rancher deploys Kubernetes for you and thus can manage it for you. So you can, of course, deploy one of the hosted ones or import any existing ones, but for these two, it's actually being managed by somebody or some organization for you. So if I look at the cloud VMs, for example, I can just go in here and create a cluster, and I've just got my AWS credentials attached to it, and I'm going to create a HA cluster. So I've now done 2 single node clusters, and I just want to create a highly available, highly resilient Kubernetes cluster with my AWS credentials. All you have to do is give a name to the node pools. So a node pool is the set of VMs with a specific role. So for example, if this node pool is only for etcd, because etcd needs to be you need an uneven number to have it HA, right? It does leader election. So I would just give the name etcd. So this will be the name of the VM, and then dash, and then the number of that VM. So 1, 2, 2, 3. And then etcd, I'll choose a template. I have 2 VM templates already in here, so I'll choose the 2 CPU 4 gig one for etcd, and I'll create a new node pool for the control plane. Also dash, just because the name, if I go to AWS, then I like the name not appended to the number. So this one as well, I'll also do 2 CPU 4 gigs, select control plane, and then I'll add my workers. And these I'll beef up a bit more. So 4 CPUs, 16 gigs. So this is how you could create multiple node pools for different roles, but also afterwards edit these clusters. So if I were to create this cluster, I can just go in and edit. And let's say I want to add a machine that has GPU capabilities or is a lot bigger or has bigger disks or whatever you want to do, right? So these VM templates are just exactly the same as you would do it in AWS. So if it needs a specific VPC or specific security groups, all of these things are just the same as you would do in that specific cloud. So you create this template once, and then you can use it afterwards. So if you want to add new nodes afterwards, you can. If you're using Azure, for example, you can't mix and match multiple node sizes, at least not the last time I checked. And if you were to do it with Rancher, with the VMs, basically, just the Azure Cloud Compute, you can create your full HA cluster with multiple node sizes and multiple AZs, for example. So you have full control over that. So highly available, highly resilient, 3 nodes specifically for etcd, 2 for the control plane because it's doing its active passive, and then 3 for the workers because, hey, maybe I have some database in there that's also doing leader election. So like this, 8 nodes, latest version, Candle, I'll also leave the same, and I'll just click create. So this is now spinning up a highly available 8 node cluster. And here I can see that my custom cluster has also already been created. So this is the Docker node that I spun up, right? So these are, you can see, of course, the containers that are still running on this one. So that one went up fine. It used Docker to just provision the cluster, and then now it's available in my environment. Let's say you want to have you want to maybe add some edge device, or you have a resource constrained environment. Maybe you're running something like a Raspberry Pi or something with only 1 core, 1 gig of memory. Of course, we can also use that, but then for that, I would recommend checking out K3s. So let's just add that one as well. Oh, this one can go, so I'll just exit this one and this one as well. And let me go to this server. Yes. And then for this one, this does not have Docker installed or anything like that, right? So I don't have to install Docker if I want to use K3s, because K3s by default uses containerd. What I do need to do is get K3s. So if you go to k3s.io, you'll get a single command which you can pipe to shell. Of course, if you don't want to pipe to shell, just get the install script and then run it in the machine itself. But I trust us, of course, so I'll just use it. So I'll go in and paste this in here, hit enter, and then K3S has everything it needs to set up a fully functional Kubernetes cluster for me, including a local pod provisioner for dynamic storage creation as well. So if I deploy K3S, I can just go in and start deploying my applications, and they will, if I create a PVC, it'll actually create a PV for me using local storage. As you can see, this is already up and running. It's added all of the binders I needed, so I can just use them from my terminal. It has created simple kill and uninstall scripts for me to leverage as well. And of course, it's added all of the systemd files as well. So now if I do kubectl git nodes, you'll see I have a single node cluster, which is running Kubernetes version 1.18.4. And this is K3S setting itself up, and now I can use Kubernetes. So if I want to add this to my Rancher instance, for example, I would just go in, add an existing cluster, right? So I'll just import an existing cluster, and I'll just demo K3S, create. Now, same thing for this one. I'll just copy this file, go into this terminal, paste it in. Here, same thing is happening again. Watch kubectl git also just running everything it needs to. Again, those node agents to just import that existing cluster. Like I said, we have this local path provisioner for your storage provider. It has a metric server already in there. It comes with traffic installed. It has a Helm controller, so you can even create an appliance with K3S, so you can add your Helm charts to a specific directory, for example. And then whenever K3S starts up, it will spin up everything needed to then, well, it will deploy your Helm charts and maybe also any pods or manifests that you have in there as well. So this is just connecting to Rancher. If I go into Rancher, you'll see that the demo K3S is also in here, right? So super simple. If I look at the node itself, you can see I have 1 gig of RAM and 1 CPU. So a resource constrained environment now also available to me in Rancher. And what do all these clusters have in common? Well, first of all, they might be in completely different places. But what Rancher does for you is that now you can go in and, for example, or probably you do this beforehand, but you could go in, attach a central authentication backend to Rancher, right? So whether you're using your AD or LDAP or like we're doing with this one, using GitHub, right? So you would log in, you would attach that central auth to Rancher, and now you can use the users from that backend inside of Rancher. Whenever you connect that, all of those users get specific roles already, right? So you can set your roles from a very high level to a very low level, and you can customize those roles as well. And depending on what access you have, you might go in and see only your specific cluster and only your specific project. And of course, you have that now. I'm not going to go into the clusters themselves of how Rancher works because most of them will look, well, all of them look the same, but of course their infrastructure might differ. So you'd just be able to go in, select your project. You can go in and deploy your workloads from here as well. You can also deploy Helm charts from here as well. You can add your own Helm chart repositories and deploy them. If you use your clusters, or if you have a cluster that is deployed by Rancher or a custom cluster or one of the cloud VMs, if I click here, you can see there's a bunch of things that you already see, and then we come a bit into the Rancher securities features, right? So I can rotate the certificates for this entire cluster. I can create snapshots of the etcd database. By default, it also does that for me. So it creates snapshot at a certain interval. I can create a template of this cluster. And with this ArcE template, I can, for example, say, hey, instead of I provide the cluster template to the users, but I am still the one in charge of what Kubernetes version might be chosen, or maybe I do allow them to override it, or maybe I need a specific network plugin in that environment, or a private registry, or even if I want to enable CIS scanning by default, right? So, and I want to set that in default. So all of these things you can set in the template, and then you enforce them, and then the user, when they might want to go and add a cluster, they won't have these options. They'll only have the choice between the template that you've created for them. So if I go into my cluster itself, so the one you also have is run CIS scan, and I can choose permissive or harden. I'll just click harden and run. So these you can set to a schedule as well. And then automatically, if something changes in the cluster, it will notify you. And I can see my scans here at CIS scans, and then it will do all of that automatically. So there are a bunch of features in Rancher, but those are mostly Kubernetes related ones, right? So CIS scanning, of course, is related to Kubernetes. So you can do CIS benchmarking as well. We also have, for example, pod security policies on your nodes. So this one is hardened. So this one has a few things that fail. So it tells us, hey, this failed, and you might want to look at this to change it, and the things that have passed, and you can skip and etc. So that's just in there for the cluster itself. We also have on a global level, for example, you can create pod security policies, and this is stuff like can a container run privilege? Does it have to? Can it use the host network? Even down to certain capabilities that can be used on the pod level, right? So all of those things, just Kubernetes resources, but made easier through Rancher. So I've went almost 5 minutes over what I wanted to. So, but this, I'll just end it here, because Rancher does provide you certain features that Kubernetes has to offer, and also integrates more features like CIS scanning as well. But in order to better understand what's happening inside of your cluster and do preventative security and see exactly what's happening, you want to use a tool like what Ramon is going to show you. So Ramon, I'm going to hand it off to you to make you do the whole intro about that.
So good morning, everyone. Let me start by just a small introduction on how we are actually able to secure your container environment. Right. So when we're talking about Prisma Cloud Compute, we are basically talking about a console and defenders. And the console is a GUI that you will use, and of course, it's API based. You can have your EIM rules defined in there, who can see what. And as soon as we see something in your environment, we will send you alerts into the GUI. The console is being fed by the intelligence stream, and the intelligence stream is a stream that consists out of 30 commercial and non-commercial feeds that actually helps you get a view on what kind of vulnerabilities you have, IPs, malware, crypto miners, etc. And the way we are actually feeding the console is through defenders. And there are multiple ways you can actually deploy defenders. So if you have, for example, an EC2 instance or a VM that you want to do vulnerability scanning on, you can actually use the host defender for that. And with the host defender, we not only scan for vulnerabilities on the host itself, but we also create a host model that basically maps everything from a service perspective that the host is doing, and then you can actually monitor on that as well. And we do the same for the networking part. Then as soon as you deploy a runtime engine on top of it, you can actually deploy the container defender. And with the container defender, you can not only monitor the host, but also all the other containers that are running on top of that host or node, right? And then we have the serverless part. Basically, if you are using Lambda or Fargate or functions from Azure or Google, you can actually use the Rust Defender or the App Embedded Defender to actually monitor those environments as well. Then if we go all the way, what we say is shift left, you can actually use the Twist CLI binary we offer to do pre-scans on images that you are using to, you're planning to use to actually build your application on top of. And we also can scan registries, repos, be embedded into pipeline tools, etc. So this is just a very quick high over on actually the architecture. So when you have deployed your defenders, so let me show you first how that works. So you can actually deploy a defender through a single defender setup, very straightforward. You choose the options that you have, you copy and paste it in, you SSH into your host and you copy and paste it, or you can create a daemon set as well, right? Same here, you download the YAML Helm chart, you apply it in your Kubernetes environment, and then you will have your defenders up and running. So as soon as you've done that, of course, you can check it. Then the defenders will actually connect to the console, and the first thing that you will see is everything you have running on your environment. So every node that has a defender attached to it will actually send information to the console about the containers that are running and that the namespaces that are defined. And then we will actually map by color from a you can say a severity threshold on, okay, these are the critical vulnerabilities that you have, for example, or these are the high. You can specify where you want to dive into. Do you want to dive into a specific collection? You can also do that. So a collection is something we use to define namespaces. So you can actually say, okay, user A can see only collection A, while user B can only see collection B. And you can do the same from a compliance perspective. Just by clicking on compliance, you will get the same layout, but of course different colors, because this is a check on a compliance perspective, as well as runtime, right? So now you can actually see what type of runtime events there are in this environment. So the way it actually works, you can take this approach on different manners, but let's say that you want to dive into this particular namespace and you see that in the SockSwap namespace, you have this front end and you see by color that this has a few critical vulnerabilities, right? Just by clicking on it, you can see actually what image is being used. You can also see, of course, if there are any runtime events or compliance events. If that's not the case, then that's perfectly fine. And you can see here by the little bit of more grayed out area, what it was you're actually pivoting into, right? And then just by clicking on it, we will show you what kind of vulnerabilities you actually have in this particular container running on a specific image. And now you can dive into it. So you can actually say, okay, we know that the severity was high because that was the reason we actually pivot into this. We show you the package information, CVE numbers, if there is a fix, yes or no, but also what the impacted versions were, when this exactly was discovered in your environment, and when this was actually published. And then if you want to use this, for example, in a specific rule, a vulnerability rule, you can actually use the tagging in that as well. So you can create exceptions based on a text that you specify here in the CVE security policy that you can build. So that's one thing. Of course, we will show you compliance if there is any, but we also show you the layers of your manifest, right? So now you can actually see where the vulnerability resides. And then if you are using, for example, Dive, you can actually see, okay, this is what I need to update, or am I using the latest version of this specific base image, yes or no, etc. So we give you a lot of information. Also the process information, package information, what host is running up, are you using trust groups, yes or no, and if you're using labels, we will show you that as well, right? So that's one way of actually looking into it from a vulnerability perspective. What you also can do is as I mentioned, you can actually have a vulnerability rules set up. So you can actually very easily say, okay, from a example rule, I'm creating an alert threshold. Let's say it's high or uncritical. We want to block on critical. This rule applies to this specific container, images, labels, namespace, whatever you want to use. And then you can actually create your advanced settings where you can say, well, we only want to apply this rule if there is a fix available. As I just showed you, we actually show you if there's a fix available for a specific vulnerability. If that's not the case, and even though this is a high and critical, you will not act on it because there is no fix, right? So you will have, of course, an alert, but we know that you can't fix it because there isn't any fix, so the rule will not be used that way. Then you can actually create an exception here as well. So you can say, okay, when we hear about a specific CVE, and we know that there is a specific CVE in here, but we are, even though we know we need to use this particular image, you can actually create an exception. right? And as I showed you, you can use an tag that I just showed you, right? But you can also say, okay, a specific CVE number, and if we see that, we don't want to alert or block, for example. So you can actually create exceptions based on CVE or tags. Then what you can do is you can actually build in a grace period. So let's say that you have a block on all criticals, right? But let's say you have a block on severity high, and you want to have some specific alert on this, right? But what you do not want to do is actually make the So what you don't want to do is have the production environment being impacted by the rule you created directly. So you can actually create a gray out period. So you can say this rule that I'm actually configuring right now will only apply for vulnerabilities published more than, let's say, 10 days ago or 5 days ago, right? So this will basically say, don't act on this right away, but give the developers the chance to actually solve the problem before this rule kicks in, right? So you have full control on actually what you're doing. And the same applies to the CE. I can actually embed ourselves into Jenkins, but if you're using CircleCI or Jar Jar or GFrog, you can actually use a Twist CLI to enforce policies in your pipeline. So that means that you can actually say, okay, when we see a specific X happen, you should fail the build, basically. And that's something you can enforce here as well. So you can actually add rules here that apply to your pipeline. And then if you do that, you can actually see, for example, in your pipeline itself, let me check. In your pipeline itself, that the build will fail, right? So, and this build, when it's being failed, nice word, you can actually say, okay, but where did it actually fail and how and why? You can actually see that back in here as well. So this is basically all your CI checks, and you can actually see, okay, why did this particular build fail, right? It failed because you actually had a critical defined, for example. So we go very far from a CVE perspective. We do the same for compliance. So with the compliance setup, so if you want to pivot into compliance, you can actually do the same. You just click on it, dive into a specific container. You can do it based on color or name or whatever you want, of course. You can click on the compliance part, and we show you the same information, right? So the way we actually help you out also from a vulnerability perspective is we actually have a vulnerability explorer. Because as we all know, there's a lot of vulnerabilities in your environment, and it's very hard to actually focus on, okay, what should I fix first? And that's something we help you with by saying, okay, we have this vulnerability, we have this behavior of this particular container, and those two those two sets combined make that you should have a look at this particular vulnerability first in your environment. So we can, if you think this is interesting, we can pivot into this later on. But I have a certain set of time, and what I really want to dive into as well is our runtime. So let's say that you have your containers deployed. So the first thing that we are actually doing is we are mapping the behavior of the container. So the first hour we will just look at the container, what is it doing, how is it behaving, and then we will create a container baseline for the first hour, and then we will monitor that baseline the next 23 hours. And then by default, after 24 hours, you have this baseline on the behavior of the container. And then you can actually start monitoring that container and use that baseline to secure your environment. So that basically means that as soon as you have a baseline created, you can actually see what this particular container has been doing, right? So you can see, okay, this is the general information. These are the processes that we have seen. This is from a network perspective that we have seen, file systems, etc. And the cool thing about this is that you don't have to do anything about this. This is completely automatic. So there is nothing you have to do. Just deploy your containers, let the defender create a container model for you, and you can use that model actually to monitor everything you are doing from a container perspective. So if you want to make adjustments, that's possible as well. You just copy it into a rule, and then you can actually make adjustments into the rule itself, right? So based on this particular container runtime model, you can also create policies. So what you can do is say, okay, I want to have a specific policy and I want to alert for a specific process or a specific networking environments, or I want to even create my own rules. So I can say, okay, I have a specific check I want to do. So I select a rule that I created, I choose it in my policy, and then based on that, I will actually monitor that container from a behavioral perspective. So that's pretty cool, because what this means is that if we see something in this particular container that has not been learned, you can say, and put in the container model, we can act on it, right? So now you can see that we have, for example, runtime events. So, okay, what type of runtime events did we see? So here you can see that we have 2 runtime events in this particular container. And now if I want to know more about this, I can actually dive into the forensics. So I can actually see, okay, what actually was the reason that this runtime event occurred and what happened here, right? And you get to see the full history of this particular container in this particular forensic view. So that's very powerful, because this gives you actually a very easy way to actually secure your containers from a runtime perspective. So even though if you, for example, if you have a vulnerability in your front-end containers and you are aware of that, and someone is actually getting into your container but does all different stuff that is not in your runtime model, we will block that, right? So just by saying, okay, we see actions that are not in the runtime model, we can actually help you protect your container environment with that. So that's pretty cool. Of course, we also have the alert view, right? So we can actually show you, okay, these are the events that we see. This is from a, for example, from a network firewall perspective. This is some events. These are just from a container audits, right? We have a host file integrity check alert, right? So that's pretty cool. And if you are familiar with OPA, we can actually act as an OPA admission controller as well, right? So what we can actually do is we can say, okay, use us as the OPA admission controller. You can actually create your rules in here by the rego syntax that you are used to use, and then you can actually monitor that from a compute perspective as well. So now what you can do now is go to the events, for example, and then if you see any hits on that particular rule, just the admission audits, we will show you as well, right? So what we can show you is, okay, this is the alert, this is the raw data request, etc. So you can actually see exactly what happened and why it happened, and you can actually use your OPA policies in the compute console. So the way that we actually are helping you defend is of course through the defenders, as I showed you, but we can also offload alerts into different other solutions. So just by simply creating create a new profile and selecting, okay, we want to have this particular message to Jira or Slack or even to a Xor, the Misto. You can actually say, okay, this is what I want to do, this is what I want to check on, and then as soon as we see something, we actually offload the alert to the predefined provider as you have created this rule for, right? So that's pretty cool as well. As mentioned, we also have the possibility to actually create a, you can say a selection or a collection of namespaces or containers based on labels, where you can say, okay, I only have this particular collection, and when I have this particular collection, I can actually use this collection in my RBAC functionality. So I can actually say, okay, when I have a specific collection and user A can actually only see collection A, where user B can only see collection B. So you can really segment your environment based, for example, on namespace or based on container images, etc. So that's another cool things. And of course, you can use the tags. From an authentication perspective, we have a lot of authentication integrations. Of course, there's a local database. We can actually use the groups in here as well, LDAP, SAML, so whatever you want to use. And then we have the more general system options, as I show you here, right? So as mentioned, we have the Twist CLI tool. This is it's a very small binary you can use to do pre-checks even before you get into your pipeline tools, right? But if you have, for example, the intelligence stream, this as mentioned, this is the stream that we have for providing actually visibility on vulnerabilities and black IPs, etc. You can actually say, okay, I want to check it every 24 hours, but if you want to change this, that's possible as well. And you can be very granular, right? You can say, okay, even when it's negligible, I want to see it anyway, right? So that's something you can do as well. And then you can actually feed, for example, the system with custom feeds. So if you have your own tip platform or you have different sources and you want to create a list with this based on name and MD5 hash, you want to put it in here as well. So we can actually use that to scan your images as well. That's also possible. And of course, there's a possibility to backup and restore from a daily, monthly, and weekly base. We do that by default. If you want to change anything or create a manual backup, of course, that's possible as well, right? So, so what we didn't touch right now is the compliance part. So just a few minutes into the compliance part, we can actually help you with your compliance perspective, from a compliance perspective as well. So as you can see here, what we are doing basically is based on the types that we offer. So that's the sysce, the image of the custom images that we are custom rules from based on images that we push in ourselves as well. And you can create your own custom rules as well, as explained before, right? Based on that, you can take actions. So you can actually say, for example, okay, I want to fail on this particular one, or I want to ignore this one, or you can actually play around with it and say, okay, this is what suits me best in this particular, from this particular image perspective. But what you also can do is actually say, okay, when we are creating this, we want to use the GDPR template, right? So from a GDPR template perspective, so this is not from a GDPR compliancy perspective, but from a GDPR compliancy template perspective, based on the actions that you should do, you can actually say, okay, do this from a GDPR perspective or a PCI perspective, for example. The thing is that you always have to put this in yourself. We will never put anything on fail, just because we don't want to introduce any friction on a production environment because you are using this, for example, right? So that's one thing. As mentioned, you can actually create your own custom rules. It's pretty straightforward, right? So if you say, okay, I want to check if there's a specific file, if it exists, yes or no, it's just simply bash, right? So you can create the rules, your own rules, very, very, very easy, and then use those rules again into, or use those custom policies again in the compliance rules that you are actually creating. And then, of course, when you go to the monitor part, we show you from a compliance perspective how compliant you are, and then we help you here as well, right? So, and we can do this for containers, of course, and images, the same as we do for vulnerabilities. We can actually show you everything, right? So there is no from a functionality perspective, there is no difference between a compliance and a vulnerability check, right? Because we do that also on the images, on the hosts. We show you everything.
Yeah, and thanks for the presentation. It always amazes me how much it can see inside of a cluster. So it's perfect how these two things can work together. Greatly, I don't think is a word, but work together very well. I do maybe want to touch on the events. Like I said, I did a very cool event with you guys myself, and I'm sure other people would want to as well. So before I do that, let me share my screen, and then I'll just take your events page and our events page and just show you how they can contact us if they would like to. So if everything is okay, you should be able to see the screen. Yeah, so from the Rancher event side, right? So this was more of a meetup. We do a lot of events as well. I saw a whole list of events at Palo Alto as well. But we have master classes we can do, which you can also see on YouTube as well. A bunch of rodeos you can also attend, where we go more hands-on into how you would deploy Rancher itself and the clusters. We're also going to be doing a developer rodeo, if I'm not mistaken, and I'm sorry I forgot the exact date, but I'm sure it's down here somewhere. I think it was somewhere in August or something, probably. It doesn't matter. Just check out this events list. We have normal rodeos, which are basically, well, simplified, generic, how to install Rancher, how to start off with your clusters. And then we're also going to be introducing developer rodeos, where we're going to go through the whole create your image down to creating a Helm chart and then deploying that as a catalog in Rancher and all of that developer good stuff, right? So check out the Rancher events page for the rodeos, masterclasses, and all of those events. And Ramon, I think this is the correct page for you guys. So you can talk about this and I'll scroll down slowly while you do so.
Yeah, well, we have a lot of events, right? So the events basically positioned on the Prisma Cloud Enterprise functionality are the capture the flags. So if you are Googling capture the flags, Palo Alto Networks, you will get to those. And if you want to test the Prisma Cloud Compute part, you can actually go to the marketplace, or you can send me a mail, and I will bring you in contact with my colleague Dan Vulture. He's responsible for this region as well, together with me, and we will make sure that you get a license so you can try it out yourself.
Awesome. That's I would highly recommend joining one of these capture the flags because it's super fun, and I think you can also still win something if you're in the top three.
Yeah. No, absolutely. That's that's the part Dan takes care of.
Yeah, exactly. So that's that. I think the thing for me was that I during the capture the flag I was doing it and I I completely forgot that people can then go in and capture your flag again. So while I was trying to solve issues somewhere else, people were stealing my flag. So I dropped down and did not end up in the top three, but I'll definitely try it again. So it's a
Yeah.
very
You
cool
just let me
setup.
know when, right? I can help you on the back end.
Yeah, exactly. Okay, awesome. So, thanks a lot. So, like you said, you can get in contact with us, with either Dan Vautour or Ramon de Boer, or me, Sheldon Lonu, or Jeroen Overmaat, the regional director for EMEA, or for the North EMEA and the Benelux. And thanks for joining. Thanks for staying on, and special thanks to Ramon for showing us how cool Prisma Cloud is.
Yeah, thank you for the opportunity, and have a great day, everyone.
Thanks, guys. Have a great day. Bye bye.
Bye bye.